Welcome to tutorial 2 of how to compute with MATLAB. This tutorial will focus on MATLAB scripting, answering what a MATLAB script is, how to write a MATLAB script using inputs and how to output in MATLAB, as well as plotting in MATLAB. We will also briefly cover how to call scripts from other scripts in MATLAB, as we'll see is a very natural thing to do. We'll also introduce the idea of a for loop. Before we start coding anything today, let's make sure we're in the right directory. So to do that, we're in the users, then mine, Dropbox, numerical analysis, MATLAB practice. And then inside MATLAB practice, we have these two folders. Let's go into tutorial 2. Now there's nothing there yet because we haven't created any scripts. Now from tutorial 1, we saw things like defining variables, say a equals 2, say b equals 2 times a minus 5, and so on. But what happened when we changed the value of a? If we change a equals 3, a now equals 3, but what is b? B is still its original value. It doesn't update even though we might want b to still have that same value, 2 times a minus 5, except a is changed to 3. So this is where scripting languages can come in handy. Instead of having to go back retroactively and rechange all of our variables ourselves, we can handle this in a script. So open up a script, we can go to the left-hand side, new script, and it brings up this blank sheet. Now inside this script file, let's just define our variables again. Say a equals 3. Next, let's say b equals 2 times a minus 5. And to use this script, we have to then go ahead and save it. So to save this, let's just save this as testing variables and save. And now we can go back to our MATLAB window and say, well, let's just call that variable, or that script, excuse me, testing variables. And we can just start typing in the first couple letters and use tab to try to autofill. Hitting enter, we see a equals 3 and b equals 1. Okay, so let's now go back to our script file. And if we change the value of a, say a equals 5, we can go back to our command window, rerun the script, and we get the new value of b as well. We can make this more complicated, say going back to the script. Let's make another variable c. Say c equals 3 times a plus 2 times b. So now we have this third variable c that depends on both a and b before it. Saving this and going back to our screen, let's just rerun testing variables. We can use the keyboard shortcut, hitting up arrow, going back to testing variables, hitting enter, and we get those 3 values. Now at this point, why is scripting any more advantageous besides just having to go back and retroactively change some variables when we update new ones? Well, if we go back to the script file, we can see before we had every single letter printing out to screen, A, B, and C. And the reason was, even though we see this highlight in orange, to terminate that statement, meaning that it will suppress the output on the command window, we just have to add a semicolon. So let's keep the semicolon there for C. And let's just change the value of A to 2. Going back to the command window and rerunning, we see, well, now our only output is C equals 4. Next, the thing we'll look at is we've been going back to that scripting window and changing A ourselves. We could do almost all of this from the command window. We just have to adjust a few things in our script. So let's go back to our script. We see that this very simple script just calculates 2 variables based on previous variables defined. And everything cascades from knowing what the value of A is. Now it'd be very nice if when we call this script, testing variables, if we could just put in that input of what A is right there from the command window. And this is the powerful tool of using methods or functions in MATLAB. So we can define something called a function, just writing the word function, and then let's use testing variables, our same script name. And now we can do these brackets. And let's just put back a equals 2 for right now. So if we go ahead and call this function, testing variables, we see the same thing. It's calling that same script by the same name with that function. But what would happen now is, what happens if we get rid of this a? Let's just delete it. And then let's just put inside these parentheses after testing variables this letter a. And what this means now is when we run testing variables, we have to put in some number a, and then the function will run itself, b will be defined, and c will be defined accordingly. So going back to the command window, if we just tried running testing variables again, we would get this error, and it says not enough input arguments. Again, that's because we did that parentheses a. So if we go ahead and just type up, and let's just put in some number, say 5.5 now. We put in 5.5 as that input a, and we'll get a new value of c as well as a new value of b. And this is the powerful tool of using these types of functions. We can input as many things as we'd like, and we can also output as many things as we'd like, even though here we're just simply inputting one number and we're outputting essentially one number to the command window. Now, we can output that number to another variable. So if we go ahead and look at our function again, we're just saying we have this function, then testing variables. All that's saying is MATLAB's expecting this to run, but itself isn't returning any variable names. To do that, we can say, let's return something called val. And setting that equal to what we call testing variables. What this means now is when we run testing variables, we better be setting the function val to something. And let's just set it equal to val equals c. So when we set this variable, we can go back to the command window and call a new variable as the output of our function testing variables, which will be equal to c. So let's save this. Let's go ahead and say, call this output variable, and let's just use testing variable again. And testing variable, let's let a equal 2 this time. So letting a equal 2, we see, okay, we have c equals 4, val equals 4, and output variable equals 4. But the thing to note is, in our workspace, we now have this value of c equals 4, and output variable of 4. Before we move on, let's just clear our command window, CLC, enter, and let's go back to that script, and let's just suppress some of these outputs. So let's not have it print a screen for val or c. So now if we just call testing variable or just rerun the last thing we did, we'll only see output variable being printed to that command window since we suppressed the output using those semicolons. Now if we go back to the script, why this is very important is we're not always going to be just wanting some values to pop up or variables to use in the command window. We can write numerous amount of functions where the functions are also calling other functions. So for example, in MATLAB, we could define another function right below, say function, we want to return some value. Val, again, is just some dummy variable that we're naming. And let's just call this give me random number. Okay, and let's just put in b, some input b. And for this particular function, we haven't defined it anyway, but we're expecting some number to be in there called b, and we're expecting to return some number val. So as this name suggests, maybe we want to just return some random number. And let's just set that value. So val being set now, and let's just have it times b times rand1, meaning remember from tutorial 1 is just a random number between 0 and 1. Since we're looking at rand of 1, that'll just return one number. And we're just multiplying that number by b. And why that might be important is, well, if we go back up here, we can define another variable called d, and we could just say d equals give me random number. And we could use, say, C as that input. So now we're returning some random number that's getting multiplied. Again, if we look at, we're feeding in, give random number, we're feeding in this input C, going to what this is doing, that's taking whatever input we have and just multiplying it by a random number. And let's return D now. So now looking at this output variable, we're returning now instead this value D, since we're setting val equal to D, and val is what we're returning out of this function. And all essentially D is just whatever C is, going back to the input of our give random number, is just that times some random number. Now the point that I want to address here is I've been reusing some of these variable names. I reused val as the output twice. Now each function is independent of the other functions, so we can just use arbitrary variable names if we wish. Of course this might get confusing, so we should name our functions accordingly. But as you can see, even though I'm passing in a variable called C here, I don't need to call the input where I'm defining the function also as C. It just has to be some dummy variable. On that note, however, a lot of times what it's good practice in scientific computing is always commenting your code. What comments mean is leaving little statements about what your code does, so if someone else or yourself return to this code, you know exactly what it does. And we can comment things using the percentage sign in MATLAB. So if we write this percentage sign, anything after percentage sign, MATLAB will not run. So you can add as many comments to the code as you really want to. It'll just treat it as though it's there, but it can just skip right over it. So for example, we can just say input A. What is A? A is a number. We can say output val, a number. Of course, these are very, very terrible comments right now, but if we had a very more sophisticated code, we could rewrite what these comments are. So for example, what's also good practice is when we write functions to define what these functions are. So we can write a lot of these percentage signs. Just doing a quick copy paste. And now we can just write function and just write what the purpose is. This function returns or outputs a random number that is generated between 0 and 1 and multiplies it by a number b. And we can do the same thing up here if we want to just say what this function does. Now, these functions are very, very arbitrary, but of course just having these functions defined as having these functions commented is good computer practice. So we can just say what this function does, returns a random number that is generated by first defining a couple other variables before it. I don't know, something like this, but something that you know and can recognize and use that later to understand what your program's trying to do. Okay, so let's go back to our command window. Before we do anything else, let's just clear the window itself, CLC, enter. And if we look at the workspace, let's just clear all those variables. We can clear variable names individually if we want, so say clear A, that get rid of A, but we can get rid of all of them just by doing a clear all. Sometimes this is good practice. For us, it's really just kind of arbitrary at this point. But what we want to do now is, let's do another example of a script, except this script, what we wanted to do is, let's input a vector, And then let's have it return or have the output be that each vector component evaluated at a specific function. Okay, so let's go ahead and go over to our script. Let's open up a new script by hitting this plus sign, and we can call this something else. Let's call this function evaluate. Let's do a quadratic function. And we want the input to be some vector. Let's call that vector x. So we have inputs, just x, vector of values, and we also want the output to be y, say a vector of other values. Vector values of the function, of the quadratic function evaluated at x. But let's just go ahead and put function. We want output y equals evaluate quadratic function. Let's go ahead and save this really fast. Okay, now we save this function. Now what do we want this to be? A quadratic function. So we want something that, like, the ith component of y is equal to some number a times the ith component of x squared plus some number b times the ith component of x plus some number c. So to do this, we have to define three numbers, a, b, and c. Let's just go ahead and do that. A equals 1, say, b equals 2, and let's just say c equals 17 for good measure. Now to actually evaluate the vector components x, or the function, or that quadratic at each vector component x, we want to say something like the first component of y, again the first component because MATLAB starts indexing at 1 and not 0, is equal to a times the ith component of x, which is the first one, squared, plus b times x1 plus c. And again, we can do that for the second component of y as well. A times x2 squared plus b times x2 plus c. And we could keep going on to the third one and to the fourth one if we wanted, doing a little copy and paste action. Oop, this plus sign, this equal sign needs to be a plus sign, and just changing those 2's to 3's. And again, we could do this even for the fourth component if we wanted. Again, this is a very tedious task, but we can keep doing it. The only problem is we don't know exactly how long that vector x's could be. It could be 2 components. It could be 100 components. Surely we don't want to list out 100 components like this. What happens if we go ahead and try to run this function, though, for a vector that's only of length 2? Let's go ahead and try that now. So going back to the command window, we can say x equals 0.25 and 0.8, a 1 by 2 vector. So if we go ahead and try to evaluate, say, y output, just some arbitrary name, equals that function that we just wrote, or that script, evaluate quadratic function, with the input x. Let's see what happens. Well, we immediately get an error because we only inputted a 2-component vector, and we're trying to create in our script what looks like a 4-component vector, only from 2 data points. Again, x3 and x4 don't actually exist from this input x that we just gave it. So how can we bypass this? Well, one way is, say, basically by using while loops or for loops. What we mean by this is basically a for loop is going to let us basically say a statement. I'll just comment it out for now. But we want to say is for I, for every component I in that vector. So we can say from component 1 to the last component of x. We want it to do something. What do we want it to do? We want to say that the ith component of y, let's just throw on a little comment for good measure, is equal to a times the ith component of x squared plus b times the ith component of x, again, plus c. And then after all that's done, we end this. This is essentially what a for loop is going to give us. We just have to rewrite this in the way we want to translate this mathematical idea into the correct syntax for MATLAB. Luckily for us, we can say almost the same thing as we began. For I equals 1, for the first component of that vector, we want to iterate by ones. So we're going from component 1, 2, 3, and so on. And then we want to say to the last component of x. What is the last component of x, though, going to be? It's going to be the total number of elements inside of x. And lucky for us, there's a MATLAB function called length that just gives us the length of that vector. And then we can go ahead and close this loop by throwing on an end. And now we can define each component of our vector. Even though we want to say y of I, the way we can say that is the ith component of that vector by putting I in parentheses is equal to a times x of I squared plus b times x of I plus c. And this will do exactly what we want it to do. So let's go ahead and test that really fast now. So going back to the command window, if we just try that same thing that just gave us an error, again, we're putting in that two-component vector, x equals 0.25 and 0.8, hitting enter. Oh, we still get the error because we haven't gotten rid of that junk we wrote before, so let's get rid of that. Now trying this, lo and behold, we get different outputs. So what is 17.5625? Well, that's just putting in the value x equals 0.25 into the quadratic as we wrote it here. Similarly for the second component of that output. Now we could define x to be any length vector as we want. We could throw in some random vector, say it has 100 components. Let's just throw the semicolon on so it doesn't blow up the screen. And now we can try to do the same thing for the output. Just go up, y output, now we're just changing it for this new vector of x. And let's just throw a semicolon on here to suppress the y output from showing up on the screen right now. And we can just type y output using a transpose, so instead of a row vector, we get a column vector, and we can see all those values. So this is one of the powers of using functions. We can quickly change some variables and insert other variables and rename them in specific ways and use functions for various different purposes. So let's just clear this screen really fast. So the last example that we want to do today is using our evaluate quadratic function. Let's create another script and let's have it plot the output. Now again, we could do this right inside the evaluate quadratic function, but just for our purposes to see that we can get scripts to talk to one another, let's just go ahead and do the latter. So let's open up a new script. Give this another name, say function. Let's say, please plot output. Of course, this is an arbitrary name. We could call it please plot plot. Something like this, whatever we want. And let's just go ahead and save that. Okay, so saving this output, what do we want as the input though? Or this function, excuse me. We want the input to be two vectors, say x and y, and what do we want to do? We just want to plot this. So again, just some good practice, inputs, x, y, vectors of values, nothing important. Of course, if we had some other important code, we could write some better. And outputs, we don't really want any outputs, so we're not going to have any. All we want this function to do is just to plot the vectors x and y against each other. So lo and behold, MATLAB has a function to do this. It's called the plot command. So if we don't exactly remember how plot works, we can of course go back to the command window and just type help plot. And just by doing that, MATLAB will bring up this helpful window that gives us a lot of different options, so much so that it's almost overwhelming of how we can plot things using MATLAB. Let's just clear this screen. Of course, what a lot of people do is mostly go to Google and just ask Google how to plot in MATLAB, which is also very efficient. So just going back to our script, all we have to do is use this function plot, and then even just as it pops up before, you see this yellow screen where it tells us what type of input it can take. We can just do plot x and y. And what this really does is very self-explanatory. X, the first variable here, is going to be whatever your horizontal axis, and your y is going to be whatever the independent variable on your vertical axes. So if we just go ahead and do this, and if we go over to our window and just say, well, what is plot? Try hitting enter, we'll get some errors. Oh, sorry, we called this please plot. We get errors because we don't have any inputs. So we could do some inputs. Of course, we want our inputs to be that large vector x that we defined before of random numbers, as well as whatever that y output was in association to it, corresponding to it. So just hitting enter, this other figure pops up on the screen. This figure doesn't look like what we'd imagine. It looks all these connected lines. It doesn't really look like a quadratic for us, so much so. But why is that? Well, when MATLAB plots things, it tends to connect the points. And since we just have these vectors in no particular order, it's just essentially connecting a lot of randomized points together. So if we go back here and just say, well, in our plot function, we can just change this from connecting the points and just say a star. And we just put that right after the y, a comma, and then apostrophe, the star, and apostrophe, and then just close that out. And we can see what happens if we go ahead and plot it again. Now we see something that looks more quadratic, but of course, just the way how we plot this quadratic, it's that c equals 17 really doesn't, kind of messes things up a little bit for us. Other things we can do with the plot command, though, is we can give this types of axes. So if we want to give an x label, we can say x label, our x values. We can call them random x values. And our y label, quadratic values corresponding, or just quadratic values for now. And we can give the x label and y label command. Those will just label out our axes for us. X, of course, being horizontal, y, of course, being vertical. Even though we call this x label and y label, it doesn't correspond to what we called our variables whatsoever. And we just have to put these inside these apostrophes as what we want the titles to be. So if we go ahead and run this again, where is that plot? Oh, it's behind everything else. It's hiding away. We see we now have some x labels and y labels on our plot. Another thing we can do, though, is going back to our script. And what happens if we want to change that color? Well, MATLAB has a lot of different options for how to color graphs. I suggest trying to Google MATLAB plot and colors. We can stick essentially a lot of the beginning first letter of a lot of colors, like R for red. If we go ahead and go back to please plot, rerun it, we'll see that our plot shows up in red this time, and things like that. So MATLAB has lots of plotting options as well. We can also add in a legend. So if we go back to our plot window, after y label, we can just stick in legend and just say legend name here, very creative. And if we go back to plot and rerun this, we'll see that some data with legend pops right up. So of course this is saying we have legend name here, pops up. Now what's interesting about MATLAB is we can plot multiple things on the same plot. So for example, we could say, hold on a second, we want to plot something else, literally typing hold on. Since we don't have another function, let's just multiply this by, let's just multiply y by 2. And let's plot this in blue. So blue, B for blue. Let's do this star again just to not have all those lines connecting. And let's tell it to hold on as well. So if we go ahead and plot that again, it'll plot two sets of outputs. But notice now we only still have one legend here. And the way we can get around that legend name is basically we have to go back to our plot and just stick in another string or letters between these apostrophes here. So this is legend name 2. If we rerun this, we'll see legend name 2 popping up, which corresponds to the blue dots. So MATLAB has lots of options for plotting, but again, the big picture here is, first we ran the evaluate quadratic function for that vector x. We got some outputs, then we fed those outputs into another function. We could almost automate all of this if we wanted to, and just have please plot x and y, call the evaluate quadratic function. So for example, we could say, let's get rid of those inputs x and y. Let's say x is equal to a random vector of 1 through 1,000. Let's suppress that output. And now let's say y is equal to the evaluate quadratic function at x. So now we have two new values of x and y, but what's special here is we're calling that function we made before already inside of this MATLAB function. So all we have to do is call please plot plot, and it'll evaluate the quadratic function at x and then plot it. So let's go ahead and try that again. Too many arguments. And this is of course because we just changed the please plot plot to not have any inputs. So let's just get rid of that input. Hitting enter, we see we get two new values. Again, we do this automatically now. Instead of that middle ground where we use the command window to call evaluate quadratic function and then pass the information into please plot plot, we just said, hey, please plot plot. Why don't you call that other function yourself? So MATLAB has the capability to do that, and it's very strong. So at this point, this is going to end tutorial 2 in MATLAB.